All right, let's dive into something we talk about all the time, energy. It's a word we use constantly, right? But what actually is it? And when we use it, where does it all go? Let's figure it out.
It all starts with something you probably do every morning. You pop a slice of bread in the toaster, you push down the lever, and a couple minutes later, you've got toast. It seems so simple. But that one little action is driven by electrical energy, and that's where our whole story really kicks off. But here's the thing that might make you pause. That electricity flows into the toaster, but it doesn't just disappear into the bread. The energy you're paying for has to go somewhere. And figuring out where that is, well, that's the key to understanding just about everything, from a raging forest fire to how your own body works. So, to get to the bottom of this, the first thing we've got to realize is that energy isn't just one single thing. It's more like a master of disguise. It's a concept that shows up in all these different forms all around us all the time. For example, think about the raw, kind of chaotic thermal energy you feel from a fire. That's the energy of atoms just jiggling around like crazy. Now compare that to the super organized, directed electrical energy flowing through power lines. They look and feel totally different, right? But believe it or not, they're both just different faces of the exact same thing. And get this, energy can also be stored up for later. The food we eat is packed with chemical energy, locked away in molecular bonds, just waiting to power our bodies. Or think about an archer pulling back a bowstring. They're literally storing up elastic potential energy in that bent bow, ready to be unleashed. And honestly, the list just keeps going. There's the radiant energy we get from sunlight, the sound energy in music, the absolutely immense power of nuclear energy locked inside atoms, and of course, the simple mechanical energy of anything that moves. It is, quite literally, everywhere. Okay, so here is the really crucial part. These different forms of energy, they don't just sit there. They are constantly changing, swapping from one form to another in what you could call a great energy exchange. And yeah, of course, physicists have a name for this: energy transformation. This is the engine that runs our entire universe. It's what makes a star shine, what makes a car move, what makes it possible for you to even lift your arm.
Let's bring this right back to your home. Think about a light bulb. Its entire job is energy transformation. It pulls in electrical energy and transforms it into two other kinds: radiant energy, that's the light we actually want to see, and thermal energy, which is just heat. It's why a bulb feels hot to the touch.
Now, let's put some really simple numbers on this. A joule is just a unit we use to measure energy. So if we pump 100 joules of electricity into this light bulb, we might only get about 5 joules of useful light out of it. The other 95 joules, they're transformed into heat. But, and this is the key part, notice that 5 plus 95 equals 100. The total amount of energy is exactly the same. Nothing was lost. It just changed its disguise. And that one simple observation, well, it leads us to one of the most fundamental, most important, absolutely unbreakable laws in all of physics. It's the golden rule that dictates every single energy exchange in the entire universe.
It's called the law of conservation of energy. And it's simple, but it's huge. It basically means that all the energy that has ever existed and all the energy that will ever exist is already here. You can't make new energy, and you can't destroy old energy. You can only change it from one form to another.
All right, let's watch this law play out in real time. Picture a diver standing way up on a 10-meter platform. He's perfectly still. Right now, all of his mechanical energy is stored as potential energy. It's the energy of his position, all thanks to gravity, just waiting to pull him down. So up top, before he even moves, it's all potential energy. 100%. And kinetic energy? The energy of motion? It's at 0. But the second he jumps, that all starts to change. As gravity does its thing, that stored potential energy immediately starts transforming into kinetic energy. He starts moving faster and faster. And right at the halfway point, it's a perfect 50-50 split. Exactly half of his starting potential energy is gone because it is turned into an equal amount of kinetic energy. The two are in perfect balance. And here we go, the final moment, just before his hands slice into the water. He's at his lowest point in the air, which means he's moving at his absolute fastest speed. That energy transformation is almost complete. And boom, at that exact instant, pretty much all of that potential energy he started with at the top has been converted into pure kinetic energy. It's all motion. And here's the incredible part, the proof.
Whether he was at the very top, in the middle of the fall, or at the bottom, his total amount of energy was always exactly the same, 6.4 kilojoules. The type of energy changed completely, but the total amount was perfectly conserved. It's amazing.
Okay, so we've got it. Energy changes form, but the total amount stays the same. But there's another piece to this puzzle. It's not just about what happens to the energy, but also how fast it happens. And this brings us to the whole idea of power. Just think about climbing a flight of stairs. Now, whether you walk up or you run up, you're doing the exact same amount of work, right? You're lifting the same body over the same distance. But running feels way harder, doesn't it? That's because you're transforming all that energy in a much shorter period of time. You are using more power. And that feeling, that's power. It's simply the rate at which energy gets transformed, and we measure it in watts. So when you see something as 1 watt, that just means it's transforming 1 joule of energy every single second. And this whole idea of power, it brings us full circle right back to where we started. Our homes, our appliances, and yeah, our electricity bills. You know, every single appliance you own has a power rating on it, measured in watts. And that number just tells you how quickly it gobbles up electrical energy. A laptop just sips energy, nice and slow. But something like an electric stove, that's a high-power beast. It transforms a massive amount of energy every second to get things cooking. This is exactly why your electricity bill isn't just about watts. It's measured in kilowatt hours. It's a measure of both power and time. It's not just about how powerful your microwave is, it's about how many minutes you actually run it. A label like this helps you figure out the total energy that appliance is probably going to transform over an entire year. So let's circle all the way back. If that golden rule is true, if energy can't be created or destroyed, then think about what that means. You can't technically waste energy, and you can't really save it. It just changes from one form to another. So the real question, the real challenge for all of us, isn't about using less energy. It's about getting much, much better at transforming it into the forms we actually want. More light and less wasted heat from our light bulbs. It's about mastering the art of transforming energy wisely.